In this short video lecture, I'll be demonstrating how to generate a few graphs and descriptive statistics for variables of interest in our dataset. We're returning to the dataset we've looked at in earlier video lectures. This is a dataset that I derived from the ECLSK as part of the EDAT system from NCES. In short, this dataset just has a few variables included in it. Right now we have a child ID, a reading test score, a math test score, highest degree attained by the teacher, and a variable that we've cleaned, which is a binary indicator of whether or not the child's teacher has a master's degree. But one of the first things you may want to do when you are looking at descriptives is to get an idea of the distribution of some of your variables. So a useful tool for this can be creating histogram graphs. So I return to my do file editor, and you'll notice that I have created a comment using the asterisk to indicate that the code below is going to create a histogram. Now the code for a histogram in Stata is simply the word histogram, followed by the variable name that we want the histogram for. So let's choose the reading test score. I'll copy it from above and place it after the word histogram. If I simply copy this command and go to my execute do button, Stata will generate a histogram of the reading IRT skilled score. We notice this data has a certain right skew with a number of values out towards the right-hand side or the positive side. It looks like there's a number of variable or values that are not there as we get closer to 0, which might give us some idea of the range of this variable. I could run a similar command if I was also interested in the distribution of the math test score by again using the histogram command, copying the variable name for the math score, pasting that after histogram, highlighting and clicking the execute do button. We can see again that the math test score has a similar distribution to the reading test score. Alright, now graphs are very useful, but sometimes we also want solid numbers for our descriptive statistics. Stata has a useful command called summarize, or I'll just abbreviate it sum. We'll type sum, and then we'll use the name of the variable we're interested in. Take again the reading test score, and place that after sum. If we highlight that and run that code, and then return to the Stata output window, we will see that Stata has given us some descriptive statistics for that variable. In particular, we have the mean, standard deviation, min, and the max. Now, sometimes we want more information than that. The sum has an additional option, which is to use sum, the variable name, and comma detail. So again, we're going to pass the argument of detail to the sum command. I'll highlight that code, click the execute button, go to my output window in Stata, and now I see that I have an additional set of descriptive statistics. So in addition to the mean and standard deviation, which we saw before, I now have information about the variance, the skewness, and information about the median, as well as various other percentiles. Then again, I can run a similar command for the math test score by typing sum and copying the math test score, placing that after the sum command, running that code. Stata would give me the mean, standard deviation, min, and max for the math test score. Now, often as we begin to generate our descriptive statistics, we're interested in descriptive statistics and the way in which they vary by other groups. For instance, in this data set, we might be interested in whether math test scores are higher or lower for students who have teachers with a master's degree. So the final command I'll show you is a version of the sum command where I condition on the type of degree that the teacher has. So again, I'll begin by typing the sum command, the variable name for which I want information. In this case, it's the reading test score. But now I'm going to add an ending condition. I'm going to say if master's degree equals 1. So this conditional segment of the command is simply telling Stata, only give me descriptive statistics on the reading test score for students whose teachers have a master's degree. Now notice again, as we've mentioned in other videos, that when testing a conditional, you have to use the double equal sign. This is a common area in which people may make a mistake. If you use a single equal sign, Stata will give you an error message. Alright, so if I highlight this code and run the code, return to the Stata output window, I get information on the mean, standard deviation, min, and max of the reading test score, but only for 4,500 or so students whose teacher has a master's degree. Now, if I wanted to compare that to teachers without a master's degree, I could simply copy the same command, paste it below, And this time change my conditional to master's degree equals 0 so that I can get the information for students whose teachers do not have master's degrees. If I was to execute that line of code and return to my Stata output window, I would see that I now have information on the other 10,000 students whose teachers do not have a master's degree. From a quick comparison, I can see that the values don't differ probably to a significant level, but differ a little bit, right? We can see that teachers without a master's degree, their students on average have a test score that's slightly higher, 35.19, compared to students whose teachers do have a master's degree. We can also see that the range is slightly different, that students of teachers without a master's degree kind of push a higher range, a higher maximum value than students that have teachers with a master's degree. Now again, we'd want to run some statistical tests, t-tests, to see whether these differences are actually meaningful, and in this case it looks like the mean probably would not be. But this does give us an indication of how these descriptive statistics may vary for each of these two different groups. So again, in a quick summary, what we've introduced here is the histogram command, simply histogram and the name of the variable for creating a histogram. The sum command, sum and the name of the variable. The sum command with common detail in order to give us things like the median and other percentiles. And then a version of the sum command with a conditional so that we can see descriptive statistics only for students of certain groups, in this case, students with and without teachers with a master's degree. These can be great commands to help you out as you begin developing and exploring your data, and these commands should be enough to get you through early assignments looking at descriptive statistics on your variables. I thank you for your time, and I hope this is useful as you continue your work with Stata.